A couple things to help you get going on this worksheet. I think you can do the top part right here. I just wanted to take you through one quick example down here. Basically, all you need to know is you need to solve for x. So in this particular case, when we subtract 11 from both sides, we get 2x squared equals negative 48. Divide both sides by 2, I get x squared equals negative 24. Take the square root of both sides, I get x. Sorry, I had some white out on there. X equals the square root of negative 24. So we can rewrite that as x equals I times the square root of 24. And 24 equals 4 times 6. So it's really, you think of it as the square root of 4 times the square root of 6, and that becomes a 2. So x equals I, oops, sorry, the 2 goes in front of the I, square root of 6. All right. The other thing I wanted to give you an example of was part 4, dividing complex numbers. So we're looking at that radical conjugate. So the radical conjugate, remember, I is actually a radical number. It's the square root of negative 1. So the way we got rid of these a while back was we multiplied it by what was called the radical conjugate. And in this case, it's the exact same numbers, you just change the sign. So I'm going to multiply my numerator and my denominator by 1 plus 4i. And if it helps to make the boxes on the bottom and multiply them that way, that's fine. So again, on this one, your radical conjugate is 5 plus I. So numerator and denominator multiplied by that. We learned how to plot yesterday. So remember that the x-axis is your real numbers, the y-axis is your imaginary numbers. So 3 minus 2i, you go over 3 on the x-axis, down 2 on the imaginary axis, and I'm going to put an A there because this was letter A. Okay, on the back side. Okay, so we've got the absolute value. So basically all the absolute value is it's the distance between z and the origin in the complex plane. So honestly, I found this a lot easier to do when I thought in terms of Pythagoras. So when I sketched this one out, negative 4 plus 3i, because they give you this formula, and it just confused me, but it really just is Pythagoras hidden. So if I'm at negative 4 plus 3i, I'm right there. And what I'm looking for, this distance z, I'm looking for the hypotenuse. So I know with Pythagoras that a squared, which is 3, plus b squared, which is 4, okay, will give me my c squared. So I'm just doing Pythagoras for this. And I didn't say negative 4 because it's a measure of distance, and that's always positive. So 3 squared, we're going to call this z, plus 4 squared equals z squared, because Pythagoras a squared plus b squared equals c squared. So 9 plus 16 is z squared, 25 equals z squared, 5 equals z. Okay. So that distance on the complex plane is 5. Z equals 5. So again, I would strongly recommend that you sketch this out. For this, it's just a straight line, so the distance is pretty easy to find. It's negative 3i. You're finding the distance from the origin to that. 1, 2, 3. Okay. This C, you're going to need to set up a triangle to help you. Okay, that's your help for this particular activity.